All right, so here's the first day of the 2.2 homework, U substitutions. Again, the key to these problems is that you're looking for a function in a function, you're looking for a function in its derivative, you're looking for functions separated by 1 degree, fractions with functions in the numerator and functions in the denominator. And usually what we pick as U is that function in the function, is that function that's 1 degree higher, is that function whose derivative we see. So, number 1, I see a function inside a function. I see 5x plus 3 inside something cubed. I do, in a sense, see its derivative since I don't see any other variables in the problem. So I pick my u value, take my derivative. This isn't the correct coefficient, so I'll divide by 5 on both sides. Now I'm able to rewrite with my u value, substituting in for 5x plus 3, my du value that includes the 1/5. Now I'm able to take my antiderivative. I substitute 5x plus 3 back in, and then of course don't forget about plus c. Number 2, a little bit more straightforward because not only do I see a function in a function, but I see the derivative of x to the 4th, I see x to the 3rd. So I pick my u value as x to the 4th plus 5, I take my derivative, but I don't have the correct coefficient. So I divide by 4 on both sides, getting 1/4 du. Now I'm able to make my substitution. So x to the 4th plus 5 gets replaced with u, x cubed and dx get replaced with 1/4 du. I'm able to find my antiderivative, and then I substitute back in x to the 4th plus 5 for my final answer. Number 4 is very similar to number 1 in that it looks like I don't have the function's derivative, but I do see a function in the function, and the fact that I don't have any other derivatives tells me, or pardon me, any other variables tells me that I do have what I need, since the derivative of 2 minus x wouldn't have a variable in it. Pick my u value, take my derivative. I don't have a coefficient of -1 in the problem, so I move the -1 to the other side, and now I can make my substitution. The negative in the du replace dx, and then 2 minus x becomes u. Find my antiderivative, substitute back in 2 minus x, and I've got my final answer. Number 5, not only do I see a function in a function, but I see the derivative of x squared because I see x to the 1st. The fact that I don't have the correct coefficient, again, is easy to fix. So I pick my u value, I find its derivative, I don't have the coefficient 4, so I divide on both sides. 1/4 du will replace the dx and the x. 2x squared plus 3 gets replaced with u. Find my derivative, simplify, and then substitute back in. Number 6 is a lot like 1 and 4. I do see a function in a function, and the fact that I don't see any other variables anywhere else in this problem tells me that I do have the derivative of 5x plus 2 because the derivative of 5x plus 2 wouldn't have a variable. Pick my u value, find my derivative. I don't have the coefficient 5 in the problem, so I'll divide 5 on both sides. Substitute my u value back in, find my antiderivative, and then substitute back in the 5x plus 2. Number 7, I see a function in a function. I see the derivative of x to the 4th, so I pick my 1 plus x to the 4th. The derivative is 4x cubed, but I'm missing that coefficient of 4, so like we've seen in so many of these problems, I'll divide on both sides by 4. Substitute the 1/4 in the du for dx, substitute in 1 plus x to the 4th for u, find my antiderivative, simplify, and solve. Again, I see a function in a function, I see the derivative of x squared, I see the derivative of something with x, they just don't have the right coefficients. So I pick my u value, I find the derivative, but I notice the 2x plus 2, if I factor out a 2, is going to match my numerator now. Of course, I don't have this coefficient 2, so I'll divide both sides by 1/2. 1/2 du rewrites for my dx. I replace my x squared plus 2x plus 3 with u, find my antiderivative, do some simplifying, and I've got my final answer. We are going to spend a little bit more time on this. This is one of the most important antiderivatives that we see. So if you're having a little bit of trouble, feel free to ask questions in class. but we are going to spend more time working on this to really try and understand. See you soon.